Hello everyone, and welcome to our class video about proving with segments and angles. Our learning goal for this video is that you'll be able to apply geometry postulates and theorems to prove statements about geometric figures. This is a pretty weighty topic, so let's jump in. You'll want to have this reference page handy. Okay, you might just put a finger or bookmark there in your notes if you want to look at it throughout the video. This is a list of our postulates and theorems for our first 2 units in geometry. You can look, if you don't know which page number it is, look below the video. I've put a note about what page number this is in your spiral. Okay, so notice all of these are postulates and theorems. We've got some called postulates, some called theorems. Before we go on to actually using these, let me talk just in brief about what those mean. So a postulate is a fact or relationship that is assumed to be true without proof. These are common sense principles, and basically what we're saying is that they are so basic to the way the world works and the way geometry works that there are no facts that are more basic than that to use to prove that it's true. There's no point in proving it if it's so basic. So let's look at an example. One of the first postulates that we learned in this class was the segment addition postulate, which explains the basic relationship that if Q is between points P and R, then I know that this piece plus that piece will add up to be the whole thing. Okay? That addition is pretty basic. Okay? We can't get more basic than just saying 2 segments add up to be another one. Okay? So that's why that one's called a postulate. Alright, now for a theorem, these are facts or relationships that are proved to be true using postulates and other theorems. Some of these are basic, some are much more complex. Let's take a look at one of those. One of the theorems that we've used in Unit 2 is the vertical angles theorem, which, by the way, I'm not sure if your version of the reference page has that name in there. You might add the name vertical angles theorem to it if it's not there. Even though this seems like a pretty basic fact, where if we have angles on opposite sides of intersecting lines, then they're congruent. But there are more facts more basic than that that can be used to prove that angles on opposite sides of intersecting lines are congruent. Specifically the fact that those 2 are supplementary and those 2 are supplementary. But we can get into that later. Okay, so we've got postulates and theorems. Now let's get into actually using them. In our first proof, we're going to prove one of the theorems that is on your reference page already and show where it comes from. We're going to prove this theorem, the third one on your list, to be true. Angles supplementary to the same angle or congruent angles are congruent. So we've set up the proof so that our given statement, what we're starting with, is that angle 1 and 3 are supplementary, and angle 2 and 3 are supplementary. So both of them are supplementary to the same angle. We're going to prove the outcome of our proof is going to be to show that they are congruent. So we're showing that the if-then statement, which is kind of implied here in that theorem, comes out to be true. Okay, so let's get started. When writing a mathematical proof, we always begin with the given information. That is always our first statement. So I'll put down our given information. The angle 1 and angle 3 are supplementary. Notice that I am abbreviating. Angle 2 and angle 3 are supplementary, and the reason for that is that that's what we're given. That's what we're presuming to be true already. And by the way, you guys can abbreviate too. Okay, so every statement following that one must follow directly from the previous statements or from the picture. Okay, so whatever statement I write next for statement number 2 has to come from statement number 1 or from the picture. So how could I use the fact that 1 and 3 are supplementary and 2 and 3 are supplementary? Well, I do know what supplementary means, so I would say that measure of angle 1 plus measure of angle 3 equals 180 degrees. I can also say that measure of angle 2 plus measure of angle 3 equals 180 degrees. What's my reason for saying that? Well, it's because I know what supplementary means. Definitions are also appropriate statement or appropriate reasons for a statement. So here, my reason is definition of supplementary. Notice again, I'm abbreviating. Okay, I know from there, hold on. So next what we'll want to look at is how we can get closer to the statement that we are trying to prove. Basically that angle 1 is congruent to angle 2, or the angles have the same measure. So I'll need to get from where I am now in statement 2 to that point. Okay? Well, let me show you how it works so you can use it in the future. Okay? We have here in this second statement that measure of angle 2 plus measure of angle 3 is essentially the same thing as 180. So what I can do is I can take those and replace the 180 over here with measure of angle 2 plus measure of angle 3. That would get me this equation. Measure of angle 1 plus measure of angle 3 equals what I've now replaced 180 with, measure of angle 2 plus measure of angle 3. Okay, now what's the reason for that? Well, this is one of our algebra properties that we looked at in the previous video. We're basically using the substitution property, because it says if A equals B, if two things are the same, as they were here, then A can replace B and B can replace A in any expression or equation. So I used measure of angle 2 plus measure of angle 3 and replaced 180 with it. So my reason for statement number 3 is the substitution property. Okay, so we're getting closer. How can I get it from here to show that the angle 1 and angle 2 are the same? Well, if you notice, I've got measure of angle 3 written on both sides of the equation. I could get rid of those. So if I subtracted a measure of angle 3 from both sides, they would both disappear. And I would be left with measure of angle 1 equals measure of angle 2. Okay, what's my reason for that? Well, what I did was just subtract from both sides. So, if you recall, this is the subtraction property of equality. Again, it's one of the ones off of the algebra properties sheet. Okay, am I finished? Well, my statement doesn't quite look like that one, but it flows from that, doesn't it? Okay, so I could go from there. Statement number 5, angle 1 is congruent to angle 2. Well, why is that? Well, that's just what congruent means, right? So I'll say definition of congruent angles. Again, I'm abbreviating, because what congruent angles mean is that they have the same measure. Okay? Because my statement matches the prove statement up here, then I know that I'm finished. I have just proved one of the really important theorems from Unit 2. And that is that angles that are supplementary to the same angle or congruent angles are themselves congruent. I'm just abbreviating what the property that we just proved. Whew. Okay, so let's look at one more example so that you can see how this works. Okay, so just to get you a little more exposure to it, I guess. Alright, so here's a second proof. We're given that angle ABD is congruent to angle YXC. So I can go ahead and mark that on the picture since I know that it's true. So let's see. And angle YXZ is over here. Alright, so I know that those two angles are congruent. We're looking to prove that the angles on the other sides are congruent. Angle CBD is congruent to WXZ. Note, I can't mark them yet because I haven't proved it yet. Okay, so, we always start with the given information, so let's go there. First statement, we know angle ABD is congruent to angle YXZ. That was given to us from the start. Okay, now we're looking to show that the angles on the other sides are congruent also. What could we use to get there? Well, we could use the property we just proved in the previous proof, right? You know, the one that said that angles that are supplementary to congruent angles are congruent. Well, these are supplementary angles, aren't they? So I could use that to help us out. But I have to show that those are supplementary first. So let's go there. Can I immediately just jump and say that they're supplementary? Well, not exactly, because there's a reason that those angles are supplementary. You'll see what I mean in a second. So first let's say the angle ABD and angle DBC are a linear pair. Likewise, I can also say the angle YXZ and angle WXZ are a linear pair. Okay, remember a linear pair is two angles that together form a straight line. Well, those form a straight line, don't they? Okay, so my reason for that is just the definition of a linear pair. Okay, now we know that linear pairs are supplementary. That's where we can pull in that they're supplementary. We can use the supplement theorem, which says if two angles form a linear pair, then they are supplementary. Okay, so then I could write angle ABD and angle DBC are supplementary. And I can also write the angle YXZ and angle WXZ are supplementary. And my reason for that is the supplement theorem. Okay, we are almost there. At this point, if I move this up just a tad, now we can use the theorem we were looking for. The angles supplementary to the same angle or congruent angles are congruent. We have established that those two sets of angles are supplementary, and they're supplementary to angles that are congruent. Going back to statement 1. Okay, so let's just finish this baby out. From here, we can conclude the angle CBD is congruent to angle WXZ. Right there and right there. Okay, and our reason for that was the theorem we just said. Okay, the angles that are supplementary to congruent angles, okay, they're both supplementary to congruent angles up here, are themselves congruent. Since our statement at the end matches our proof statement, we know that we're done. Whew! Well, have I blown your brains yet? Are they fried? Well, this whole idea of a proof takes some getting used to, so don't expect yourself to understand it completely just yet. But keep trucking with us, and you'll get there eventually. Alright, well, I will see you guys in class.